Hi, my name's Sean Lyon. This is my presentation on field effect transistors. We'll start by discussing what a transistor is in general. They're semiconductor devices with a variety of applications. Most basically, they're used as an amplifier or switch within a circuit. How they function is based on the characteristics of the silicon on which the transistors are fabricated. Adding impurities to the silicon is referred to as doping. Silicon can be doped as p-type or n-type. P-type is silicon with an excess of free holes or absence of electrons. N-type is silicon with an excess of free electrons. These materials are combined to form p-n junctions, which are then biased in order to adjust depletion regions. Depletion regions are boundaries of p-n junctions where free electrons and holes recombine. The adjustment of these regions is responsible for controlling the flow of current through the transistor. Now we will discuss what a field effect transistor is and how it compares to a bipolar junction transistor. Field effect transistors consist of 3 or 4 terminals: gate, source, drain, and in the case of MOSFETs, substrate or bulk. Field effect transistors are controlled by applying voltage to the gate terminal, which induces a field in the transistor. This field manipulates the depletion regions within the silicon and controls the flow of current between the source and drain. Bipolar junction transistors, by comparison, have 3 terminals: base, collector, and emitter. These are controlled by the current flow into the base. There are 2 main types of field effect transistors: junction field effect transistors, also known as FETs, and metal oxide semiconductor field effect transistors, also known as MOSFETs. The construction of each type is demonstrated below. FET consists of a gate connected directly to the p-n junction. Due to this construction, it suffers a gate leakage of approximately 10 to the negative 9 amps. It can only be operated in depletion mode. MOSFETs consist of a gate that is isolated from the silicon by some insulator. Usually this is made out of silicon dioxide. The isolated gate leads to the lower gate leakage value, and it can be operated in both depletion and enhancement modes. Both field effect transistors can be constructed using p-channel or n-channel methods. Field effect transistors are one of the most impactful electronic devices. The small size and wide application leads to its use in logic gates and memory, which make up the fundamental components of microprocessors and computers. They can be used to create biological and chemical sensors by replacing the metal gate terminal with an appropriate receptor. They can be used to create amplifiers for lab equipment such as oscilloscopes and multimeters, which we have used extensively in this course. Finally, the operation of field effect transistors is directly related to the manipulation of electromagnetic fields. I hope you learned a lot with this presentation, and thank you for listening.